Hi all. So today we'll be doing the volumetric analysis. A volumetric analysis forms a very important practical of class 12th and 11th CBSE practicals, and it fetches almost 8 marks for you if it is done correctly and if it is written correctly. But before that we need to learn certain nuances also, and first we'll be preparing the standard solution, after which I'll be explaining what exactly is volumetric analysis. It's also known as quantitative analysis, and we'll go ahead with the practicals. But first, for preparing the standard solution, we need to understand certain terminologies. We'll be preparing a standard solution, and basically a standard solution is a solution whose concentration is known to us, and it is prepared from certain kind of solutes which are known as primary standards. A primary standard has certain characteristics, like it is not reactive, it's least reactive, quite stable, and above all it's not hygroscopic nor deliquescent. It does not undergo any compound formation, it does not decompose, and above all it's neither toxic, it's cheaply and readily available in the market. So one such primary standard is oxalic acid. We also have certain other substances which can be used as a primary standard, but today we will be preparing the solution, standard solution of oxalic acid, and we will be preparing m by 20 250 ml of oxalic acid solution. This solution will be termed as a standard solution. In the preparation of the standard solution, the first thing that we need to do is we have to weigh out certain amount of the solute, that is the oxalic acid crystals, in order to prepare m by 20 to 50 ml solution. So how much of crystals are required to prepare 250 ml of the solution of the known concentration? For that we have few calculations. So let us do the calculations. So as you can see, our aim of the experiment is to prepare m by 20 250 ml standard solution of oxalic acid. And how much amount of oxalic acid crystals are required for this preparation of this concentration, and that to 250 ml. So here we can see, I have written over here, molarity is equal to N by V, which we already know. N here is the number of moles of the solute, and volume, V stands for the volume, which is our volume of the solution taken in liters. Now molarity, we are taking it as 1.1 by 20 or 0.05 molar, which is equal to number of moles upon 0.250. Here we have converted the 250 ml of solution into liters, so 0.250 or 0.25, and then we get the number of moles over here as 0.0125. This is the number of moles. So 0.0125 is nothing but the number of moles which is given mass upon molar mass of oxalic acid. Here molar mass of oxalic acid is to be taken as 126, because we are also considering the water of crystallization over here. 2 molecules of water are required here. So 2 molecules of water are required here. So the formula is COOH whole twice dot 2H2O, which is equal to 126 grams per mole. So I have taken 126, multiplied the same, and here I get the mass of oxalic acid as 1.575 grams, which is required to prepare m by 20 250 ml standard solution of oxalic acid. To measure 1.6 grams of oxalic acid crystal, what we require over here is an electronic balance. You can take the simple balance as well. We have the electronic balance over here. I am resetting it, I am switching it on, and I am taking this watch glass. Now the weight of the watch glass also has to be included in the mass. So I will be keeping the watch glass over here, noting down the weight of the watch glass and putting it on reset, so that it comes as 0.0. And now I will be weighing exactly 1.575 575 grams, which is close to 1.6 grams of oxalic acid. So here we have the oxalic acid crystals. It's white in color. I am weighing over here with the help of the spatula. It's mandatory to use spatula. You cannot take it with your hands. All chemicals have to be handled very carefully. So I'll be weighing around 1.6 grams of crystals. Since the calibration over here is only up to 1 decimal point, hence I'll be taking only 1.6, and this is exactly 1.6 over here. I'll be transferring the entire content of the watch glass into this 100 ml beaker and pouring water till the calibration. I'll take care that I'll always see the lower meniscus since it's a colorless solution. Having poured enough water, now the next step is to stir the solution so that the oxalic acid dissolves thoroughly. So here I am transferring the contents into a volumetric flask. This flask is a volumetric flask and it can measure 250 ml of the solution. There is a mark over here, a mark is etched over here, and we have to fill up the solution till here. So then it becomes 250 ml m by 20 solution. Since it's only 100 ml approximately, I'll be putting enough water so as to make it 250 ml of m by 20 oxalic acid solution. Also, care has to be taken that the beaker in which we have dissolved all the crystals also has to be thoroughly cleaned so that no traces of the solution or the crystals remain in the beaker. As we come towards the end, care has to be taken that the solution is only till the mark. As I go towards the end, I'll start putting few droplets in case it's not up to the mark. Just shake the solution thoroughly so that it mixes well. This is my m by 20 250 ml standard solution of oxalic acid. Using this standard solution of oxalic acid, I'll be finding out the concentration in terms of molarity and strength of another solution by what is known as volumetric analysis.